Hi, let's get started by talking about electron configurations. What I want you to do is to get your blank periodic table and get some markers or color pencils, anything like that. You will need them in a minute. Before that, I want you to look at this one that we have here and answer these questions on the bottom. You can do it either on the back side of your periodic table or attach a notebook paper and answer this question. So for group number 1, look at this. We've been doing a lot of trends lately. So we're going to do some more trends here. So let's look at group number 1. What do the configurations in group number 1 have in common? We see here 1 is 1, 1 is 2, 2 is 1, 1 is 2, 2 is 2, 2p6, 3 is 1, 1 is 2, 2 is 2, 2p6, 3 is 2, 3p6, 4 is 1. What do all of them have in common? So here are our elements, and we can see that all of them end with the same way. All of them end in S1, 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 and S1. Now take a look at group number 2. What do the configurations here, what do all of them have in common? As you can see here, they all going to end with S2, 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 but not with the same number. Here we have a 2, a 3, and a 4. But all of them end with the same letter, S2 and S2. Look at number 3. What do all of them have in common? Group number 4. Group number 5, 6, 7, and 8. Take a minute, write this down, pause the video. Okay, so you probably saw something like this. All the ones in group 3, the trend is that they end in P1. Group number 4, P2. Group number 5, P3, P4, P5, and here with the exception of the first one, which is S2, the others end with P6. What I want you to do now is take your colored pencils or pens or markers or whatever, and we're going to see all these trends, how they look like in the periodic table. So label, it doesn't matter the colors, but this section over here along with this one belong to the same block. We're going to call them blocks. Here's a different block, and a different block. This pink one, you can do it whatever color, doesn't matter. We're going to label it the S block. Why? Well, we can see that all of them in S1 here, S2 here, and this is the other one. Then we have the purple ones. They are going to come next. What do you think we're going to call these? Or this block? You probably guessed it right. All of them are going to end with P. P5, P4, P6. So start over here. P1, P2, P3, P4, P5, and P6. So this block right here is going to be the P block. This purple one, you can do it whatever color, it doesn't matter. Now, here we didn't get we cannot see it, what's coming after this part from this picture here, but all of them are going to end in D. Here they're going to end with D1, D2, D3, D4, 5, 6, 7, 8, 9, and 10. So this green is going to be called the D block. Here they all going to end in D. Now the thing is that they're not going to follow the period. They're going to go one behind the period. So this is actually going to start with 3. In contrast to this one, which starts with 4. 4, 5. This one's going to start with 5. In contrast to this one, and so on. And then let's do the last one. This is called the F block. All of these are going to end with F. So F1, F2, and so on until F14. And now these are not going to go with the period either. Here, instead of with a 6, we're going to do it with the 4. So they're going to minus the period number. Instead of going with 7, this one is going to start with 5. Now, you might be asking or wondering, what does all this mean? Well, we're going to see that whenever we add the exponents, this should equal the number of electrons the atom has. So like in this example, we have 2 and 2 and 1. It has 5 electrons. So if we use the periodic table, we can see that boron has 5 electrons. And this is actually the electronic configuration for boron. So far, what do you think that electronic configuration means? Think about this for a second. We've been talking about the history of the atom and how the atom has changed over time according to new experiments from different scientists. We had a discussion about how the Bohr model is not the most recent one, is not the one that is the most accurate one. And today we're going to look at a new model, not that new, but newer, that it's different than Bohr. And the electrons we're going to locate the electrons just like, it's going to be like a map, like even the address for the electrons, where they located. So this is all about electronic configuration. To do this, I want you to go back and watch the second video, and then we're going to continue with this. So we're going to do the hog activity first, and then